We will consider the same array we have taken in the previous example with 5 elements. That is, size of the array is 5, and we will take a value to be searched as key. First we will take a value that is present in the array, and then we will take a value which is not present in the array. Okay. And first I will tell you the basic concept behind binary search. So here the index varies from 0 to 4 because the size is 5. So first location is 0 and the last location is 4. The basic concept behind binary search is we will divide this array into 2 halves like this. First we will like this 0 plus 3 by 0 plus 4, that is the last location, 4 by 2. So you will get 4 by 2, that is equal to 2. That means 0, 1, 2. We will take first 3 here and the next 3 here. That is 0, 1, 2 will come in this half and 3 and 4 will come in this half. Now we have an assumption. If you want to perform binary search on an array, the assumption is that the array must be in sorted form. Then only we can perform binary search. Either you can arrange the array in descending order, or you can arrange the array in ascending order. Anyway, the number must be ordered, sorted form. Okay. For example, consider this case, our previous example. So in this case I have arranged the numbers in ascending order. So what will happen? 11, 22, 33 will come here, and 44, 55 will come here. Now what I will do? Suppose you want to search for 44. We have divided the array into 2 halves. What we will check? We will check either this element or this element. Now you can consider this as an array and this as a different array. So if you check this position, that is the value stored in this location 33. 33 is obviously less than the key element. So that means what? That means this particular element is not available in this array because array is in sorted form. Because this is the maximum element that you can store here. If this maximum is less than the element that you are searching, that means this particular element is not available. So what we will do? We will confine, we will check the key element. You will start checking the key element in this half. So in this half the element is available. You can see in the first location in this itself it is available. But consider another case which is 56. 56 is actually greater than the highest element in the second half. But this, after this we don't have any elements. So this is the maximum element. That means the array is, the element that you are searching is not available in the array. Okay. So for example, consider another case where you are searching for 22. If you check the highest element in the first half, you can see it is higher compared to this key value. That means there is a chance for this element to appear in this first half. Consider another situation where a small element which is not available in the array, 21. If you check this element with the highest element in the first half, you can see this is higher, so there is a chance for this thing to appear in the array. So what we will do? We will confine our search procedure here. Okay, so else we will confine our search procedure here, but in this case we cannot go for this half because it is higher elements. So this element is actually less than this one. So there is a chance for this element to appear in this half. Again, what we will do, we will continue this process of splitting the array. We will split this array into 2. Again, we will split it into 2 like this. The idea is 0 plus 2 by 2. This is the smallest index, this is the highest index. We will add them together and divide it with 2. 2 by 2 you will get. And what is the answer? 1. So 0 and 1 we will make it into a single entry, and the 2, index 2 will be treated as another array, and this procedure will continue. And this procedure will continue till you get a single element here and a single element here. Okay, at that position, if the element that you are searching is not present in the array, you can say array is not present. So I will go to the program and I will explain this concept. In this case, I have defined the array, which is this, nothing else other than this one. So this is the array. Okay, that is the name of this array. Now I have defined I, which is a loop variable, left. So what is left? This is actually the left, and another one mid. This value is actually pointing to mid. And what is right? Right means the rightmost element in the array that we have considered. And key and size, that you know. Key is the element that you are searching, and size is the total number of elements in the array. Okay, so this left and right will play the role. So how do we find another? We have another pointer which is called mid. How do we find the value of mid? Mid equal to left plus right by 2. This is the expression to evaluate the value for mid. That means 0 first time, left is 0, right is 4. 0 plus 4 by 2, 4 by 2, 2. So we will get a value for mid as 2 first time. That means based on this, what we are doing, we are dividing this array into 2 halves like this. Okay, now we will see how it is happening. Before that, we will read the elements, we will read the size, everything we will do it. If you look at this, you can see printf enter the size of the array. We are reading the size. We are reading the size of the array as 5. Okay, and then we are reading the array. All these things we have explained. We are reading the array, and then we are reading the key value you want to search. Okay, now our binary procedure will start. Okay, I have initialized the variable left and right. Left is equal to 0, as I said. Left I am pointing to this 0 here. Okay, and what is right? Right is actually I am pointing to the last element in the array, which is size minus 1. Size is 5. So what is the index of the last element? 4. So how do I get the value for this right? Size minus 1. Size minus 1. That is what I written here. This is the search procedure. While left less than or equal to right, that means if this is pointing to an index value that is less than or equal to right, sometimes this can coincide. So if it is less than or equal to size, that means if left is less than or equal to rights, what we want to do? We want to perform some operation. This much operation we want to perform. This much operation we want to perform. Okay, so first, what is the step? We are implementing this procedure. We are implementing this equation. Mid equal to left plus right by 2. Okay, so first time we will get 0. 0 plus 4. 4 by 2. We will get 2. Okay, if key is equal to array of mid. So always we are checking this one. We are checking the key value. We are comparing the key value and the value that is pointed by mid. So first time we are getting a value 2 for mid. So mid will be pointing here. Mid will be pointing here. Mid So we are checking this value with the key value. So if they are same, printf enter the entered element is found, element is present at index that mid. Okay, if key is less than array of mid, that means if the searched value is less than this value, that means what? You can find the element in this area. If not, you can find the element in this area. Okay, so right equal to mid minus 1, right equal to, that means we are repositioning, that means we are repositioning right to this location, mid is pointing to this location. Okay, so we have, in this case we have checked this position. So in the further checking we are not including this one, we are excluding this element because we already checked it. So we are excluding this element. So now in this case our left is pointing to this one and right is pointing to this location. For similarly for this array, left is pointing to this one and right is pointing to this one. Now which one we want to choose? Either you can choose this area or you can choose this area. Okay, since 33 is less than, that is mid is less than this value, so we will confine our search to this area. So in that case what we will do, in this case what we will, key is, in our case key is not less, key is actually greater than this value, so we will confine to this area. That means our left is what? Mid plus 1, left is mid plus 1 and right remains the same, because right remains the same. We don't want to reposition the right. If this value is greater than the mid value, but if this key value is less than this one, we will not change left value. What we will change, we will reposition this pointer to this one. Okay, so this process will continue. This process, the entire process will continue till you get a lower value or equal value compared to the right. Okay, now we will write the remaining portion. When you come out of this loop, that means our element is not present, that is the searched element is not present. If it was available in the array, here itself we will get the message and return, we will return. Okay, if it is not there, then only we will come out. That means when you reach this position, then we will come out of the loop and we want to say the element is not present in the array. Clear? Okay. Now we will save the program. It is binary search, so I will give the program binary search. Binary search. Now I will run the program using the GCC binary search. Now we have no errors, so you can straight away run the program. Sorry. The number of elements, I am taking the same example, 5. We are entering all these values: 11, 22, 33, 44, 55, and first I will search for this 44, which is available in the array. Element is present at index 3. So here 3, we are displaying the index only, so not the location. 0, 1, 2, 3, 44 is available here. Now I will run the same program again with the 5 same elements, but with a different key: 22, 33, 44, 55. Now I am going to search for this one, 56, and element is not present in the array. So that is the output of this program. Now we will perform the same binary search operation, but in this time we will consider function with the function. The same example and the same concept I will explain. Binary search, but only difference is in this case we will consider the binary search with the function. Okay, same example we will consider. First I will write the program. So in this case we have declared the array and we have the key, size, position, all these things are there, and printf statement, and we are reading the size of the array, then we are reading the array itself, and then we are reading the key value we want to search. Now I will write the function call. This is the function call. So here I am using the function name binary search, and I am passing 4 arguments. The array where you want to perform the search operation, and this is the starting location of the array, and this is actually the total number of elements -1. That means it will tell you the last index. 0 is the first index, beginning index, 4 is the last index, and the key element. So these are the 4 elements we are passing to the array. The binary search function will return a value which is the position of the element we are searching, and if that position returned value is -1, that means the element is not present in the array. If it is giving a value, if this function call gives you a value that is other than -1, that means the element is present in that location, and that is the main program. Now we will write the definition, function definition corresponding to this function. This is the function definition. So in this one, as I said, we are getting 4 parameters to this function. 4 arguments are there. So array, where you want to perform the search operation, left is actually the index, and right is another rightmost index, and x is actually the value that you want to search, that is the key value. So I am taking a copy here, and then I am defining inside this function, I am defining another variable which is called mid, and I want to calculate mid. So before that, what is my aim? So I want to check whether this left is less than or equal to right, then only we want to perform the rest of the operation. So that is written inside this while loop. While left is less than or equal to right, what we want to do? We want to calculate a new value for mid. How? Mid equal to left plus right by 2. So during the program execution, I want to reposition this. That is why I wrote it like left plus right minus left by 2. And if now you will get a value for this mid, and if array of mid is equal to the element that you are searching, I want to return the mid, the value of mid, that is the position. And if it is less than x, if array of mid is less than x, that means left, we want to reposition this left like this. We want to reposition left to this position. If array of mid is greater than or equal to greater than x, then we want to reposition right to this position. Okay, that is right equal to mid minus 1 to this area, to this position. Okay, and this will continue till this condition is satisfied. When this condition is not satisfied, that means, see, when you find the element, we are returning that mid. That means we will exit from this function. If we reach this point, what does it mean? It means we didn't find the element that we are searching. So if you didn't find the element you are searching, what we want to return? We want to return a minus value. So upon receiving a minus value here for position, we will say, if position equal to -1, we will say printf element is not present in the So that is the program. Now I will execute this program. Before execution I want to save it. So save C program. This is actually binary search with function. Binary search with function. func.c. Now I will run it with the help of GCC, and the program name is binary search with function. So fun is there, .c. So I don't have any errors in this program. No compiler errors are there, so you can directly execute the program by typing ./a.out. Then you will get the messages. You will get the message from this area. Enter the size of the array. The same example I am going to give us the input. So 11 is the first element, 22 is the second element, 33 is the third element, 44 is the next one, and 55 is the last element. I am going to search for this set 44, which is available in the array, and element is present at index 3. So it is showing the index. Now I will run the same program for the same number of elements and for the same elements 11, 22, 33, 44, 55. But in this case I am giving an element which is not present in the array, 56. So this is the expected output. Element is not present in the array. That's all about binary search.